same. I will partition it, then I will show. Okay, a square pyramid side of base 40, axis length 60 is resting on one of its base in the HP. Okay, so we'll draw a square pyramid square. Four. Okay. Four, enter. Age 40, enter. Okay, so now take the projections from here, take the projection from here. For axis, I'm taking projection from the center.
So your screen is stuck.
Okay, okay, wait. I was probably projecting the PPT itself. Yes. Okay, I will restart. Okay. So I take the polygon. I take the number of sides 4. Instead of the center of polygon, I select the edge. Right. Specify suitable distance from XY. Then I check the orientation. I type 40, which is the side of base. Right. Then I take the projection from this edge. Take the projection from the right edge. Right. For axis, I selected this boundary. Right. I just make sure the OSNAP is on, and I will draw a line here of 60 mm for the axis. Right. Then from the apex I will connect this. I will join this till the end point, and then we will join this. Right. So in this way the triangle gets constructed in the front view. Now this I will replace it by center line. Okay, getting? Now in the top view, that is in the true shape, we should join this in this way. Right. Then I will select this already drawn edge, match properties. See this you need to ensure. Okay, are you able to understood this, why we have made this thick? Because we can say that this is a apex, and to this apex 4 triangular faces, 1 2 3 4 are connected, and whenever we look it from top, right, the all these triangular faces will be appearing to be fitting at one apex point, which is here central portion. Okay, so how to nomenclature this? So let us take this A, B, C and D, then A dash comma A dash comma B dash comma B dash, then C dash comma D dash, then X, then Y. Okay, you can take the height of the letters 4 or 5, not too small, not too large. So this point is A, B, C, D. So this will be the projection of A dash B dash meeting to this point, right? Then C and D overlap, so this point will be C dash comma D dash, right? This is X and this will be Y. Okay, now for apex we will be taking one more point here, so let us taking this point as O, O, right? And we will copy this point to draw the O dash. Okay, now what is the height here? 60, right? What is the base? 40. Okay, now what is mentioned in the question? Draw the projection of pyramid if its axis is inclined at 45 degree to HP, right? So if the axis is 45, base also will be 45, so we'll select this along with this A dash B dash, right? Then we copy this, select the AB, switch on the ortho mode, and if required you can switch it off the OSNAP, right? And if you are compatible without switching off the OSNAP, it's okay. Why I suggest? Because sometimes the OSNAP may face the copied object to the center of the line like this. See this, right? That's why. Otherwise no need, right? If you are not comfortable, switch it off the OSNAP and keep the ortho mode on and then place it in this way, right? Now we will select this again to make it inclined 45 degree. I will select this endpoint, switch on the OSNAP again, select this point, and now I want to make this base inclined. So I will type -45 from keyboard. Let's see this. Okay, in this way it needs to be done because we take the rotation with respect to this xy in this direction, right? If you are taking in this direction, then it should be positive. As I am taking opposite, I have taken negative. So now we take the projection from this AB, then we take the projection from the base CD, right? We take the projection from the apex O, okay? And then we allow these intersections to be till this, right? This till this point, and then in this way. Okay, now we name this. This is a projection obtained from A dash B dash. This is the projection obtained from AD. So this point should be A. So copy A, right? Similarly, on the same line, this is the projection obtained from CD and this is from D, AD. So D is a common point to both. Similarly, this is a projection obtained from AB and BC. So the common point is B. We are going to get it here. And the remaining point will be C. This is the point C. Now the question is how to join. Okay. The only remaining point we need to locate is O. Okay. So now as far as the object is concerned, and if you are drawing it, right? In this which direction we are going to draw? From this direction, right? Look at this. Here is the observer, right? So we will be looking from the top direction, correct? So if you are looking in this direction, right, what we will be observing? O dash to A dash, O dash to B dash. So whatever is visible, first you draw it, right? Because whenever we will be looking from this direction, right, we see that O to A, O to B is visible. So we join the O to A and O to B. Now What is the base? Base is a square. And how do we find out this? ABCD. So the AB part is the outline of a square. So outline is always a dark line, right? I switch on the OSNAP. BC is again outline, so it should be visible, right? Then AD is also outline, so it should be visible, correct? Now what is remaining? O2D and O2C. See this. O2C and O2D again are forming outline. Look at this, right? Correct. So the all visible lines are drawn. So what is remaining? The edge which is connecting C to D. This edge, right? So this edge here is remaining C to D. So this C to D, as it is falling inside, that need to be drawn by hidden line. Okay, so I will draw it hidden line here. Okay, I will delete this, or you can make this hidden line with the thick lines. Okay, in this way. So this completes our questions answer. Now what is remaining? Angle what is made by this axis needs to be shown. Now sometimes we also need to look at the axis. So for that case, we might need to project this, right? In this case, then we delete this and then we join this O to that distance by center line to show the axis. This. Now you may see that even though we have taken this axis and with the help of center line, but still it is not appearing as center line. So in that case, what it to do? You use LT scale as a command. In this LT scale, you can see the scale factor is 1. Change the scale factor to 0.5. Say this now. The distance between the lines got increased, so because of which we will be able to easily identify the difference between the two line types. Okay, so this completes the whole answer now. Okay, so now I'm deleting this which I've taken. So let's go back to the next question. Okay, so this is a question based on the cylinder. So what is given in a question? A right circular cylinder of base diameter 40, axis 60, has a point of base circle on the HP with axis making an angle 45 degree with the HP and parallel to VP. So as the circle is making an angle 45 degree with the HP, we need to draw the circle below the XY line like this. Okay, so we will be drawing a circle below the XY. Then we will be drawing a rectangle which is the its projections, correct? So we will draw a rectangle like this above, and then we will proceed. So I will transfer this question to AutoCAD, then we will proceed. So always use a template which will be provided in the exam, right? Don't try to create a rectangle. Okay. Okay. So right circular cylinder of base diameter 40, axis length 60, has a base circle on the HP with axis making it at 45 degree with the HP and parallel to VP. So in this case, axis will be making 45, but at the same time, this base of the cylinder should be touching the HP. That is mentioned. As a point of base on the HP means whenever the axis is still making inclination, edge of base of the cylinder should be making a contact with horizontal plane. So how to proceed? So we draw a XY line like this. So changing the line type to bilayer. Okay. Then I will take a cylinder that is a base circle. In this case is 40. So I take the center point. Take the radius is 20. Right. Then from the center point, I take this horizontal line. Right. I divide the circle into the 8 parts using the polar array. I select the center point. Circle is by default divided into 6. I change it to 8 from the number of items like this. Okay. Once this is done, project this upwards. Okay. In this way. Then axis height is 60. So we take this 60. Right. Then here also we take 60. Right. From here we take 40, which is the equals to diameter, and we complete this, and this base also is reconnected again. Right. We extend the generators like this in this way. Okay. So now we name this. Prefer to give in the name of 1 2 3 4, although it is not mandatory to give the names in that format, right? But I prefer it. 1 2 3 4 5 6 7 8, then 1 dash, 2 dash comma, 8 dash, 3 dash comma, 7 dash, 4 dash comma, 6 dash and 5 dash, and x and y code obvious. These are the whole annotations we will require. So 1, so similarly if this is 1, this projection will be 1 dash, right? Then this is 2, 3, 4, 5, 6, 7, 8. Okay, so this is a projection which is obtained from a 2, 8, right? So we move it 2, 8. Similarly, this is a projection obtained from 3, 7. So that will be called as 3, 7. This is a projection obtained from 4, 6. Okay, and this is a projection obtained from 5, called as 5. This X, this is Y. Okay, so now we make the edge thick, right? We select this edge, match properties, this outer generator, this outer generator, this is a top base and this is a bottom base. So these all outlines we are making thick. Now we transfer the annotations with the same names to top view. Sorry, to top base in this way. Okay. Now we need to make the axis inclined by an angle 45 degree while making the base still in the HP or while making the base on the HP. So we select all annotations, we copy this, make the ortho on, right? And then we select this. Okay, click on this. Once we decide the position, we select it again, then we click on the rotate, right? Now we select the O snap, we select the C point which is a base. You can also select the A point, but if you select the A point you will have to tilt on the left side like this. You will have to incline in this direction, so which might lead to overlap or you will have to keep more distance then. So that's why we generally tilt it from the right side, but left side tilting is also correct. So this, what should be the angle? Angle should be 45, so we type minus 45. Okay, in this way. Now we will have to take the projections from this one. So it's matching with the projection obtained from 1. So this point is 1 dash, sorry 1. So now this is a projection obtained from 2, 8. This is a projection taken from 3, 7. This is a projection obtained from 4, 6. This is a projection obtained from 5. Okay, now we intersect these projections. So one projection already there, then projection obtained from 2, 4, projection obtained from 3, projection obtained from 6, 8, projection obtained from 7. Okay, now we can see the names. This is the intersection of 1 dash and 1, 5. So this point is 1. Similarly, this is a projection obtained from 2, 8 and this is a projection obtained from 2, 4. So intersection point this is 2. This projection is for 3, 7 and this is obtained from 3. So the common point is now 3. Similarly, we can have this projection obtained from 4, 6 and 2, 4. So this point will be 4. And This is a projection from phi and this is 1 phi. So this last point we are going to get. I will extend this. Ortho on. Okay. So this intersection point is phi. Then on the same vertical line where the force 6 is there, we can locate the 4. Sorry, we can locate the 6 just above the 4 because it's a projection of 4 6 and this is the intersection of 8 6 line. Similarly, we can look at the 7 which is on a vertical line from 3 dash 7 dash. This is 7. The last point we need to locate is 8. Okay, so 8 is on the horizontal line of 8 6 and it's on the second line. So this is 8. This point is 8. So let's move. Okay, now we can see that how to join. First, I will show you how to join the top base. Then I will show how to join the bottom base. Okay. So if you look at from the top of this figure, we can see that whole top base is visible, right? So in this case, whole top base needed to be drawn with the thick line, correct? So in this case, being a symmetrical figure and inclination is provided only with the one axis, with one plane. So we can use the ellipse command, which is here. So we can use center or axis end. Okay, I will select the axis end. Both will work. I select the axis end. I select the thickness 0.3. Okay. See what is asking. Specify the axis endpoint of ellipse. So one is the axis endpoint. Switch on the O snap. 1, 2, 5. Okay. Then it is asking specify distance to the other axis. So in this case, this is the distance to the other axis. You can see the ellipse will appear automatically. No need to use the spline command in this case because figure is symmetric. In the same way, we will take the projections for the this bottom base. Okay, see this. Now here I will show you one trick. As the figure is very symmetrical, just locate this endpoints, right? Then what you can do, you can select the annotations, select the ellipse, copy it, and okay, I need to also select the midpoint like this. 1, 2, 8. I will select. Okay, select the ellipse, copy, copy with base point as the center point of the ellipse in this way. Okay, but is it the correct solution? No. Why? Because if you look it from the top, only the outer portion will be visible, whereas the inner portion will not be visible. So in this case, what we need to do, we will trim this portion, right? And we will delete this. Okay. Then how to proceed in this case? So we will select the hidden line, right? We will select the ellipse command again, right? So we select this axis endpoint as one, axis endpoint and this, and then we'll connect it like this in this way. Okay. Then we need to connect this 7 7 and 3 3, which is a outline in this case. Okay, because we need to always connect the base, bottom and top with the help of outer generator. In this case, here it is 3 3 and 7 7. So this completes the figure. Okay, so what is remaining? Annotations. We have to take 0.09 is the thickness. Okay, so I will use match properties. Okay, then diameter. Okay, and the angle which is made by the this. Okay, in this way. Any doubts over this?
No.
Okay, okay. So let's proceed to the next question. Okay, so what's given in a question? A square pyramid of 40 mm edge of base, and axis length 60 is resting on one of its triangular face on HP. Right? Draw the projection of the pyramid when the edge of base contained by the triangular face is perpendicular to it. So if you notice closely, you won't see any angle which is given. Do you find out any angle in this given? Hello? Read the question carefully. A square pyramid, 40 mm edge of base, axis 60, is resting on one of its triangular face on HP. You can see it is shown here. This is a square pyramid and it is now resting on its triangular face. Correct? So for such cases, what I have indicated, the solid is indirectly inclined to the horizontal plane. Right? So in this case, inclination won't be given. Correct? So how to proceed in this case now? Right? So whenever the triangular face is contained in the HP or triangular face is contained in VP, based on that you will have to draw. As the triangular face is in on the HP, you will have to draw the true shape of the square on the HP. Okay. So I will transfer this question, then we can proceed. See, first we will draw a square, right? We select the edge, we select the 40, okay? We select this generator, okay? Then for the axis, we select the geometric center like this. I'm not clicking anywhere, I just dragging it the projection. Once I click on the XY, then I will take the height 60. Look at this. In the first step, I will connect this here. I will connect this base point. Then I will go back to the apex. So that we will minimize the time, right? This completes our step 1, right? Now select any one edge, make it thick. Select the mesh properties. This one, this one, this one. Now tell me whether this needs to be made thick or not. This edge. Hello. Do we need to make this thick? Yes or
So are
no?
you talking about the triangle?
Yes, we should not make it thick because it's a axis.
Okay.
Correct? If the orientation of the square pyramid would have been such a way that edges of base are equally inclined to VP, then in that case, axis overlaps with the edge, right? But this is not the case. So we make it center line like this. Okay? Now, I will give the annotations. A, B, C, D, A dash, comma B dash, C dash, comma D dash. So now see that while moving this, A dash B dash, O snap is on. So either it is fetching to the midpoint of this projection or it is fetching to the endpoint. So I'm switching off this O snap and I will exactly place it where I want, which is outside, like this. Correct? Similarly this. Okay. Then I will copy this to show the O dash. O dash, right? I will copy the one of the point of the base to show the O. Okay. Okay. Wait. What is remaining? As it is a pyramid, what I need to do? I need to show all the diagonals in this way. Correct? Correct. And now I will move this to show the apex in the base. Oh, okay. Now, how to let the triangular face on XY? For that, copy this with the base point like this. Okay, place it appropriately from the original figure. That is step 1, right? Then we copy this, right? Or instead of copy, wait, we select this along with the annotations. Select the rotate. Now closely look, huh? We wanted to align this either O dash, C dash, D dash or O dash, B dash on the XY. For that, we select the C dash D dash, which is the base point. Always look here, what I'm doing. We selected the C dash D dash, which is the base point. Now, instead of providing the angle, I'm typing a reference. Okay. Once I typing the reference or selecting the reference, I select the this C dash D dash again. Then it is asking to select the second point. So in this case, now I'm selecting the O dash point. Now it is asking what is a new point. So instead of selecting a new point, I will select the this endpoint of the xy in this way. In this way, you will have to rotate or make it align on the xy line. Hope you are able to do it. Able to understood, or should I show it again? Hello?
Hello.
How I did it?
Yes, sir. ये तो
Okay,
समझ आ गया.
great, good. Okay, so then we take the projections. So we take the projections from the base. Line thickness should be 0.09. Ortho on. C dash D dash projections. Also this needs to be extended. Then we take the projection for axis if required. Then on the O. Okay. Then we intersect this. Sorry. In this way. Now how to proceed? Okay. We transfer the annotations. Copy. Say this is a AB, this is a AD. So this point should be A and this point should be B. Okay, so I'm moving this like this, correct? Similarly, this is a projection for the C dash D dash. So this point should be D and this point should be C. So I'm copying this. Okay, and then I'm copying this O. Okay, now we clearly see that whenever we look it from top, O to A, O to B is visible. So we join with the visible line first. O to A and O to B. Okay, now we clearly see that whole base will be visible, A, B, C, D, right? So we join in a sequence A, B, C, D, A. Okay, so we have already drawn O to A, O to B. What is remaining? O to C and O to D. That won't be visible and also falling within the visible scope. So those needed to be drawn with the hidden line. Right? So we take the hidden line, connect it, O to D and O to C. Okay, so this completes the answer. And if you at all wanted to draw the center line, so you can draw the center line from this point to the this intersection till this. Okay, so this is a center line. Okay, this completes the answer. So what is remaining? Only the annotations. So what's the height? Okay, this completes. Okay, so for such question, if everything is correct, you will get 10 out of 10 marks. No deduction will be there. And for SEO 20, this could be the second stage. So out of 13 marks or 14 marks, you will get 13 or 14 as per the case maybe. Okay, as per the distribution is concerned, because next step is also needed to be drawn for SEO 20 pattern. Okay, so let's proceed. Okay, so now we will move on to the next question, which is based on the cone. One thing you might have noticed that all the problems till now I have discussed are either inclined with HP or indirectly their face is on the HP, correct? Okay, so that you can understand how the question will be framed. Say this: a cone diameter of base 60, axis 60, has one of its generator in the HP, right, and axis parallel to VP. Here also angle whatever is made by the cone with respect to the horizontal plane is not given. Now you can see what is mentioned then: has one of its generator in the HP. So in that case you need to draw the cone on the horizontal plane. Then you can see here the cone is drawn on a horizontal plane, right, and then it is tilted. After tilting, you can see this cone is like this, correct, and then you can see this top view where it is shown after the tilting, correct. So we will draw it in AutoCAD. If you have any questions, please ask. Any questions on this? Hello? Are you there? Okay, probably no questions. So can we proceed to the AutoCAD? Yes, okay, okay. So we copy this. Okay, we'll take the text. Okay, so cone of base diameter 40. So we'll take a circle with a radius 20, right? Then we draw one horizontal line from the center of the circle to the edge. We'll take the polar array, we select this edge, enter, we select the center point, and we will divide this circle into the 8 parts. By default it is divided into 6. We select this number of items 8, enter. Okay, now what we will have to do, we will take the projections like this. Okay, we'll take this projection from the center point, let it till xy, and then we will go 60 mm up from the xy line. Then we join this, join this base and join this. Okay, then we take the inner generators. Okay, let it meet into the apex. Similarly here. Okay, okay, then we select the edge, make it thick. Remember, in exam we won't be monitoring the line thickness, but if you are able to do it, please do. Okay, but sometimes because the answer may get weird if you don't at all do the line thickness. this is done. Okay, so now next step is annotations. 1 1 2 1 2 3 4 5 6 7 8 1 dash, then 2 2 dash, comma 8 dash, 3 dash, comma 7 dash, then 4 dash, comma 6 dash, and then finally 5 dash. Then I will increase the text height to 4 or 5. Okay, so here it is 2 dash. Okay, then x y. Okay, explode, then we will move this 1 see this effect of OSNAP, right? So you may switch it off the OSNAP if required. Now I am switching it off and I will place it here appropriately, nearer to the point of 6 on the edge of circle. This is 7, this point is 8. Okay, so now this is 1 dash, this will be 2 dash comma 8 dash, this will be 3 dash comma 7 dash, this will be 4 dash comma 6 dash, this will be 5 dash. Okay, x right, just slightly increase, this will be y. Okay, now I want to show the apex here, so let us rename this O. Okay, similarly apex in the front view, so this will be with dash, O dash. Okay, so now what we have to do here, in the question it's mentioned that it's has its one of the generator in the HP. So what we need to do, either we need to tilt this triangle or a cone, actually case, on the xy line with O dash 1 dash coincide with xy, or O dash 5 dash coincide with xy. So we'll do O dash 5 dash coincide with xy. For that we will copy this, right? We'll select the base point, switch on the ortho mode, right, and place it appropriately. While transferring or copying, I have kept the OSNAP off so that I can place it appropriately where I want. Then what we will do, same process we will follow as of the previous question. We will select it, right, we will rotate it. For rotating we will select the base point, which is a phi. Okay, then instead of providing the rotation angle, we will click on the reference, then we will click on the phi again and O, right, then we will select the endpoint y in this way, correct? Then if you feel that it is too much distance between the original figure, you can select and you can drag it by moving in this way. But again you will have to switch it off the OSNAP and keeping the ortho mode on, right? then you can keep the projections, you draw the projections, then ortho on, OSNAP on. This is the projection from O, okay, then projection from 1, okay, projection from, say I will zooming it little bit, 2 8, okay, projection from 3 7, okay, projection from 4 6, projection from 5, okay. You can see that it is very close, okay. So I now taken the projection from 1 5, okay, till here, and this will be our apex, okay. Now taken me from 2 4, okay. So this is the point where 2 4 will intersect. This will be a point 4 and this will be the point 2. Then 3 on this line. Similarly, this will be the 8 6, and finally 7 will be here, okay. So we copy this 1. Where is our 1? See, here is the 1. So this point should be 1, okay. Now where is 2? This is the generator of 2 8, right, and this is the 2 4. So this point will be 2. We copy this, here will be 2, right. Where is 3? 3 is on this vertical line, so 3 will be here on this point, right. So 4 and 2 will be on the same horizontal line. You can see that, right. So where is 4? 4 will be, it is the generator of the 4 2, and this is the generator or the this is the projection from 2 4, right. So this particular intersection, this vertical line and this horizontal line, so this point is 4. Similarly 5 on 1 on a horizontal line, so 5 will be, this is the intersection of 5, okay. Now 6, 4 and 6 on one vertical line, so this point will be 6. Where we are going to get 6? On this vertical line. So this is the intersection of 8 6, this is a vertical line of 4 6, so this point is 6. Similarly 7, we are going to get it on the this line. So this is the projection of 3 7, this is the projection of 7, so this intersection here is 7, and finally 8 is on the horizontal line of 6, so 8 will be here. Now how to join? Whenever we look it from the top, we see that a complete base is visible, right. So in this case we will select the thick line. Bilayer is the type of line. We select the ellipse, right, selecting the axis n type ellipse, right. We select the 1, OSNAP on 1, other end of the axis 5, then distance to the axis 7, in this way, right. Now how to draw the outer generators? Select the O, and from the OSNAP settings make sure the tangent option is on, so which was not on here, I switched it on. Now carefully go here and select the tangent, right. I will show it on the other side also. Line command, selecting the O point, go close, series, tangent option will appear, right, and touch it. In this way you will have to proceed. Okay, if any annotations overlapping, try to move if it is possible, like this. Okay, see, it is not letting, so O snap is, I am switching it off and then placing it in this way. Okay, and then I will place this O here, annotations for the base and the height. O snap. Okay, any questions over it? Hello, I hope you are able to understood this answer. Hello, hello.